All right. So we're talking about the Spark job optimization. Now, to answer this, any question which comes like my job is failing or my job is working slow, for to answer these questions, there would be three technique. There will be three way in which you can answer it. There is one like how you can optimize it using the techniques. Techniques like what are the techniques we'll see. Then there would be some workarounds which is like maybe not documented anywhere, but you can apply those and then it works.
Okay.
And then there is the best practices like okay, so I have tried everything and now this is what the job will this is how the job will work. So let's say if these are the three different category in which we can optimize the job, then what exactly we do? So what we do are predominantly these things. What I have seen, maybe there would be more on the Google or etc. But what all I have seen and is suited for the interview is like uh, I will not suggest you to answer in this sequence, but yeah,
Okay.
there are a few things which is like show short solution. Like if you'll say you will have to buy your points, which is like JVM optimization on all executors. So which is like let's say I have tried everything. Sometimes interviewer will say that no, I have tried all the memory leaks in the source code. Source code is optimized. My DAG is looking good. My I have implemented all the best practices. Still, the things are not working. Then what you can do? Then the best solution would be like you should answer that okay, we can do something related to the JVM optimization or garbage collection, or let's see how the objects are getting created and collected in the garbage during the garbage collection. So what algorithms or how well we can tweak our JVMs.
Okay.
That's we'll see in the details
Yeah.
what are the options for the JVM optimization, but I'm just giving you the options.
Yeah.
Then the first way, let's say the first answer should be like, okay, if the job is running slow, I will look into the diagram. I'll see that I have submitted the job. So how many stages has been created, like the uh, number of stages, how many tasks has been created against that stage, how is the shuffling and the partitioning happening between the within the stages or within the task. So we'll have to observe these key points by looking at the Spark UI, and then we will get some solution. Let's say we are saying that this particular task is taking longer, then there must be some scope of improvement in that task. Or if the similar task is being executed in a different executor fast in a faster way. Let's say your job has been distributed into 10 tasks. 5 tasks has been completed within few seconds, and then the 5 tasks are taking longer, and they are similar in the uh, action. I mean, the similar action are being performed on them. In that case, we can see that maybe those machines, network bandwidth, or there's something with those machines. So some pattern identification is important. How well maybe sometime you can repartition between the actions, so that before you perform the action you have done the repartition, and your data sets are equally distributed across the nodes, across the executors, and it helps. So looking at the diagram is the first way of hitting that problem optimization. Then it comes the source code optimization. I would say that it's very easy for the developer to just dive into the source code and say that okay, no, this is you read something on the Google and you say that no, this is something has been wrongly done, and it should have been it should have been corrected, and the previous developer or the current practice, we are doing something wrong in the source code. That's very easy to point out.
Okay.
But I still suggest, or I still try in my project, that when it comes to the source code optimization, take it as a second step or the third step, because uh, doing the build, trying it, uh, developers suggest something based on how they run on their local or how they run in the controlled environment, but on production the situation is completely different. And when you take your new source code to the production, it sometimes it brings more problems. So source code optimization is, unless you are very sure you have done all the prerequisites, like you have checked it on the QA, you have done the UAT, you have tried running it with the exact load, then only the source code optimization helps. So
Okay.
source code optimization in a production running situation should be the second or the third step. It should not be the first thing to try.
Okay.
Okay.
Yeah.
Mostly, initially we'll target all the configuration related stuff, because
Yeah.
config changes are easy to do. You just change the value in the config file, and when the next time the job will run, it will pick up the next config, and then it might get optimized. So this is how you can frame your answers. That the first thing how I handle it with a production situation, or if it's under the development, try everything with the config files. What all changes we can try, possible permutation combination within the config, number of partitions, the shuffling, when should we shuffle, how many executors do we need, what should be the optimum memory or the core for every executors, what should be the sizing of the drivers, etc. All these things are configurable. Try it first. Then the last thing, something which goes to the end, like now I have tried everything and there's nothing else than the infrastructure scaling, that I need more executors. In the existing infrastructure, I have tried, and I want more memory per executor. So infrastructure scaling, you can ask very easily. I mean, in the first finding itself, you will find that the infrastructure can be scaled, and then we can handle this load. But to do this, unless you are on a platform as a service, or unless you are using the Databricks or some managed services, it's very difficult to scale the infrastructure.
Mhm.
So this suggestion is the last for the interview as well as for the production in situation.
Okay.
Then there are a few key points, like you can try compressing your data size when you are reading from the disk. You can try serializing your objects in the memory. Then when you are doing some joins, or you are filtering your data sets, make sure that you just read the relevant data set. Don't Your lookup table should be smaller in size. Your joins should be not between big table and big table joins. I mean, if
Yeah.
big and big is required, obviously you'll do. But the point is, which table should reside in the memory, which table should be read at the runtime, etc. So join
Okay.
optimization uh, is can be well handled. Lookup table should be in the memory, and there are some practices around it. So we can try those. Garbage collection mechanism, like I said earlier, is again important. Persistence and caching is by default. The caching is by default, it's always in memory. But if you need to persist that stuff in the disk for some time, and then maybe in some other job is reading it, so that you can free up the memory for the other computations, you can try it. That's because your job has, let's say, multiple stages. It's you have submitted your job. It's a huge one, and it has 16, 20, or 20 stages. In that case, let's say the first stage is complete, you can persist those into the disk and you can read it later. if that's what is important. So your persistence mechanism can be improved. You can introduce the checkpointing. Like till this point, I have done my operation. Even if the job fails, I can restore from this point, etc., etc. And then at the end, so at the end, let's say now you have tried everything, and you are just to suggest the infrastructure scaling is required. We can't do anything with this job. I have read all the Stack Overflow. I have read everything, all the suggestions, and nothing works. In that case, maybe sometimes the pattern understanding is important, uh, because on the production, most of the time we have a shared queue where the Spark jobs are getting submitted, and then the clusters are getting assigned to you. So in the shared mode of working, some patterns are important. Like everybody tries to run their batch job during the weekends or the low access when the read or write are happening very less. And in that window, everybody runs their job. So cluster gets clogged.
Logged. Yeah.
Yeah, so sometimes pattern is also important. Let's not run in that window. Try to schedule your job in some other time. That also helps. So that but this for this understanding, even maintaining the logs of all the Spark job is not important. But you will have to speak with the person who had been on this project from long time, and he might tell you something verbally, like, okay, no, I have seen that every Friday this job fails. So
Okay.
that helps. You can further dig into it and then see whether all the jobs are scheduled in the Friday in that interval or not. So something verbally also sometimes helps. But yeah, the history of jobs and the pattern identification is also important. So
Mm-hmm.
why I have touched on this Spark job optimization first is like this gives the broader picture on how we will be taking up this session
Yeah.
now onwards. So yeah, before I switch, would like to hear from you, like what else you want to include in this, and how is your understanding?
I think so. I've understood the whole picture, like how optimizations can be made. Like I've understood the techniques, work around things, and also so the best practices. It's like limited to these, right? There's nothing else. Like you've like covered all of it. So I think so. This
Yeah,
is like this particular view is enough to like at least speak about Spark for in an interview for at least 10 to 15 minutes, so at least the interviewer will know that the person speaking isn't speaking any crap, so he at least knows about things of what Spark goes about. So I think so this whole picture like helped me understand the actual execution part of Spark rather than like understanding what is an RDD, what is an data frame. The last 15 minutes were like more useful for the interview, I think so, because this is the actual work that you'll be doing in Spark rather than like understanding the concepts.
exactly.
Yeah.
Right. So that was the intent. That's why I didn't wanted to take up this session with the boring concepts like what
Yeah, yeah, yeah.
RDDs and the concepts around it. But yeah, those are under the hood. Those are very important things,
Yeah.
because unless you answer
Understand those. Yeah.
these key concepts, you might not be at the stage of answering these in the interview. So
Yeah.
understanding those as well from the holistic from a perspective is important.
Yeah.
Than the what is written and the documented on the Google and the
Yeah.
internet.
Yep.
So we'll move to that part.
Okay.
I will go to the first slide then.
Okay.
Okay, so first slide, I talk about what are the things required. On my machine, I have Java, Scala, SBT, Spark, Hadoop, everything set up, IntelliJ, and everything.
Okay.
Uh, but in case you want to do the setup or you want to take this up, If these setups are not done on your machine, maybe I can take up a virtual machine, and on that I can set it up and then show you step by
Uh,
step if
yeah,
that's needed.
yeah. I think so. I was going through a course on Udemy, so I don't remember which like ID I've set up. So I'll just like check it.
Now, so the IntelliJ is I would suggest that you use IntelliJ,
Okay.
and uh, when you install IntelliJ, things would be like almost plug-in.
Oh, okay.
Otherwise, SBT, you can install SBT, you can install Scala, and then you can put the Spark. Then the best way I would say is like install IntelliJ or
Okay.
Scala ID of Eclipse. This gives you everything. I mean, but yeah, Java is required.
Yeah.
Scala is required because see, Spark is written in Scala. The built-in support, the by default support, all the libraries and etc. You will not face any challenge. SBT build is important because if you're using this stack, your Spark life becomes very easy.
Okay.
If not SBT, you can use Gradle, but
Okay.
I would suggest not to use Maven or something with the Spark because
Okay.
it brings unnecessary complexity, which is better to avoid because we are not in an exploration stage. Spark is already like
Advanced.
yeah. I mean we know what to do, what should be done, and if these questions comes up like how is your environment, then again it's very important that you let them know that this is what stack I'm using.
Okay.
So like I am using the Java 8 plus. Scala,
Okay.
again, Scala version is, you can say that I'm living with the latest 3 plus or something.
Okay.
Spark, again 3 plus. Hadoop, 3 plus. So 3 is the key.
Okay.
I'll just confirm the Scala version if it's 3 plus or something. Let's copy this. Oh, yeah, Scala is 2. Yeah, so I had a doubt. Scala is like 2 plus. SBT is should be 3 plus. SPT is 1.3 plus. Okay, these are important because these questions are, and Spark is 3 plus.
Okay.
So it's like 1, 2, 3. So Spark is 3 plus or 3, but in production it's safer to say 2 plus because 3 is very recent. Let's not say 3. Go with the 2.4 or something, 2 plus.
Okay.
So it's like SBT is 1 plus, Spark is 2 plus, Scala is 2 plus, and Java is 8 plus. Is how your environment is. Hadoop is as well. Hadoop also you can say that uh, 2 plus, 3 is very recent,
Yeah.
and let's say for you to try something before Tuesday. This is
Yeah.
this link something will help you certainly
Okay.
to try the Spark codes. You don't have to set up anything. Even if you memorize all these steps which is needed, and you set up your account with the Databricks Community Edition,
Okay.
sign up. Maybe I'll keep the sign up ready tomorrow,
Okay.
and you can run your Spark jobs over here.
Okay. Got it.
Okay. So this is something which is if nothing else works, then you can come here. All
Okay.
right. This is about like if interviewer asks that how is the environment,
Okay.
what you are using, what version of Spark, what version of Java, and etc.
Okay.
Build tool. Sometimes these questions also comes.
Okay.
All right. Then now I will come to the very basic of the Spark,
Okay.
which is like why Spark. although if this question comes, why Spark? There would be 100 ways of answering it. Spark is fast, Spark is this, Spark supports, etc., etc. But I have listed some key points, like what you should say that how Spark is, what benefit Spark brings to the uh, platform of big data analysis.
Yeah.
So you can say that in order to answer this question, I would like to highlight some of the points in which Spark brings the uh, advantage to the big data analysis when we have the big data sets and we want to analyze it to see and to take some informed decisions. We need to analyze those data sets, and it's since it's quite huge, not fitting into the memory, and we want to analyze it. So we analyze it fast. So we have to adopt Spark.
Yes.
Why? Sorry.
Yeah.
Yeah. So something. So in simple terms, big data analysis, something which is not fitting into the uh, memory of one compute node. One compute node, one laptop, one virtual machine, one computer, one compute. In
Yeah.
one compute node, even if I have 16 GB or let's say MacBook Pro, I have a limitation. I have like 16 GB of the RAM. So at a time, even if I give 16 GB to the JVM, if my Java job is running, see, Spark is written in Scala, but Scala gets converted into the bytecode. Those bytecode runs in the JVM environment, Java Virtual Machine environment,
Yeah.
right? So Java, so you and what is this virtual machine is like again, whatever size you have appropriated to it, like one JVM you have appropriated, like you can use. In my MacBook Pro, I have let's say 7 node. I have given you 4 node to use. I have 16 GB. I have given you 10 GB to use. So my JVM, the virtual machine, will have 10 GB and 4 nodes. That's one compute machine I have.
Yeah.
So in that machine, at a time, if I want to process, I can process 10 GB of data set, right?
Yeah.
Maximum. Even if I want to clog the JVM with everything and make it struggle, I can process 10 GB.
Yeah.
Or I can apply some techniques like to do the parallel processing, use the threads, concurrency, etc., etc. All the techniques. I can
Yeah.
process, let's say, 20 GB, 30 GB. Even if given the time, let's say you process it in one day, I can process up to 50 GB.
Yeah.
But there would be the limitation and or the there would be some acceptance on the time frame that okay fine, I'm processing 16 GB in 2 hours,
Yeah.
which is the problem, right? So parallelly we can process the data on one machine, but when it comes to the terabyte of data, 1000 GB I certainly cannot process on my laptop, right?
Yeah.
And it's I'm still talking about the terabyte, or let's say 2 to 3 terabytes would be again a difficult, but there comes the benefit of this part. So distributed data parallel processing, if that is needed, then Spark brings the benefit. Like unless you are processing the huge data set, let's say I'm just processing a small chunk of data and I'm distributing across 1,000 nodes. Maybe on a single machine, I can using the Python, I can process it within few seconds, but the
Yeah.
Spark will process it in certain hours. Even if maybe it takes. So this is also a interview sort of question that I have a small data set. I have a very small data set and it's taking very long time to process in this
Yeah.
Spark. Despite people say that the Spark is very fast.
Yeah.
Okay. So the problem is if it's a small data set, don't partition it across the just process it within one executor.
Yeah,
Try
don't
to,
apply multiple executors so that it
yeah,
doesn't get divided.
doesn't get divided. So, and then sometimes the question comes like, I have a data set which, let's say, all the, considering all, let's say I have 10 executor and every executor has 10 GB of memory. So essentially I have 100 GB of memory, right?
Yeah.
Yeah. And then I'm processing 1 TB of data set. Okay. So I have 1000 GB of data and 100 GB of memory. So
Yeah.
in that case, what can I do? So these are the two interview critical questions. I have a smaller data set taking long time, larger data set still taking long time. And in both the case, it's a very valid situation. It will happen because in a smaller data set uh, gets distributed across multiple executors, you have to control it. And in larger data set also, you have to create your partitions accordingly. That if you have 1000 GB data set, you have 10 executors, each with 10 GB of memory. So your partition size should be something like 8 GB, because executor will
Yeah.
not get clogged, and then it will have some time, some space additional for the compute, and then your partition should be 8 multiply 1000 divided by 8.
8.
If
Okay.
you select those sort of partitions, you get some benefit. Things
Yeah.
gets processed, then get read, and then be processed, written back, and etc etc. Things will work concurrently. But if you don't but yeah, these days these things become very automatic with the Spark engine has become very smart. The first thing it does is checks the data size and then decides the number of partitions.
Okay.
Ideally, Spark jobs, okay, so it's an important point. Ideally, Spark jobs tries to keep the number of partition based on the number of CPUs you have overall. So you have 10 executors. Every
Yeah.
executor has 5 CPUs.
Okay.
So 50 CPUs, it will try to create 50 partitions.
Okay.
Okay.
Yeah.
That's the calculation. That's the default. But these days, Spark engine has become more intelligent, checks the size, and try to limit those things. But
Okay.
for the interview perspective, you can answer it this way: that number of CPUs, number of partitions by default.
Okay.
But yeah, you can when you are parallelizing your RDDs, you can specify that how many partitions you want to create.
Yeah.
Not necessarily that I have a smaller data set and I create 5 partitions.
Yeah.
I'll just create one partition.
Yeah.
Yeah, so I can specify
Got
that.
it.
Yeah. Okay, so again, my question was like, why Spark? So I moved some other places, but yeah, it's like distributed data parallel processing. If that is required, Spark is yes. Then what Spark does? Spark does the data manipulation, right? Data manipulation, like something like select. If you are familiar with the SQL queries,
Yeah.
mostly what it does the select on the data set. It does the filter on the data set. It does the grouping, the aggregation on the data set. It does the join. It does the uh, some sort of windowing or pivoting or some.
Yeah.
I guess only these things it does on the data set, and that's only what happens with the data.
Yeah.
Because if you open the data in the Excel is the
Yeah.
best data manipulation tool. In
Yeah.
Excel,
Yeah.
yeah. So whatever
Yeah.
you can do in the Excel is what can happen with the data.
Yeah. That's right.
So if this is the data set, you can apply filters, you can format it, you can in the if you go to the data, you can
Change the
consolidate,
data
what
type.
if analysis, forecast it, everything. I mean, sorting, filtering, whatever you see in here is what happens in everywhere. SQL queries, Spark, R, Python,
Yeah.
Pandas, whatever data manipulation library you will see, essentially we will be doing only these things.
Yeah.
So despite we have all these programming language, like we have the R, we have the Octave, we have MATLAB, Python, we have all those, but they are still lacking one thing, which is distributed data parallel processing.
Yeah.
They all work with their in-memory stuff in on one machine, one
Yeah.
compute node.
Yep.
Just a minute. So that's a challenge with other languages. Other again, Spark is not a language. Spark is leveraging Java and the Scala to the core, but
Yeah.
it's a framework which is not available in the Python or the MATLAB or any other programming language.
Yep.
So this framework supports R, Python, and Java and Scala. That's where the popularity comes.
Yeah.
That despite this language by core is written in this Scala, it has some wrapper through
Yeah.
which it supports Python, it supports R, so that you can very well work in your comfort programming practice.
Yeah.
You don't have to switch. I know Java, I can work with the Java. I don't have to learn Scala.
Yeah.
For when it comes to the production version of it, maybe I would try to learn Scala. I would somehow, because Scala and Java there is very minimal difference, and
Okay.
I might prefer it. But let's say if I'm just pure Python, then obviously I will not go to the Java and Scala, and then I will just try with the PySpark
Oh, yeah.
and the Pandas.
Okay.
Pandas is the best data manipulation libraries.
Yeah.
One line of code and it does the magic, but it cannot work with the huge data set. It
Okay.
doesn't work.
Okay. Yeah. So,
So
like, Keshav, I had this one question. Sorry for interrupting.
no,
Like, in my resume also, I don't have any Java or Scala experience, and my experience is only limited to like some type of data manipulation with Python. So like during the interviews, is it fine to say that I have like understanding of Java as in terms of object oriented programming and like the concepts, but I haven't used Java, but I've used Python like for at least a year and a half or two. So does that like create a problem not knowing Java, or like is it fine?
no. So yeah, it certainly your question is uh, appropriate. Let's say
Yeah.
if I'm taking an interview and somebody says that I don't know Java,
Yeah.
and it doesn't make it's something there's something wrong in this statement,
Okay.
because see, I will have two understanding. First
Yeah.
is you have the readiness, which is very limited in the sense that the something with the thorough understanding is missing.
Okay.
Okay, because see, Python in the US or in the India or in the software industry
Yeah.
is naive than the Spark.
Yeah.
Yeah, Python adapt enterprise has adapted Python later before they had adapted the Spark,
Okay. Yeah.
right? So what impression it comes with is like and the Python is very high level programming, very high
Yes.
level in the sense like you don't have to even know anything.
Yeah. You don't have to create classes, nothing. You just have to like use the
It's
direct
a
available
script. It's a
package.
script like
Yeah.
SQL. You write
Yeah.
select a star and it works.
Yeah.
And in Python, you write a statement and it works. So there's nothing sort of programming nature of field. So one programming uh, in a comprehensive way, you will have to circle yourself. That no, I know. I have understand it. See, even if question comes, you can talk it. You can
Yeah.
budget that. Okay, fine. I don't know this,
Yep.
but saying this statement that I don't know Java certainly will not make a good impression.
Okay.
Rather, said something like, no, I know Java,
Yeah.
although I have used the Scala on top of it,
Okay.
but I'm very familiar with the concepts of the Java.
Yeah. Okay.
The with the Java also some of the and that's the reason if you'll come to my last slide, I have kept this like understanding Java is very important. Despite Scala, Spark, and etc. The
Yeah.
Java there is something which I want you also to understand, and then some key concepts are very important.
Okay.
Okay, so
Yeah.
try to wrap yourself in a with some
Like I could just like go ahead and say that I know Java. I've like worked it during my college days, but I do not have any like professional experience on it.
no,
Is
no,
that like fine?
don't use any
Okay.
negation here that I haven't
Okay.
used. Just tell him that I know something. I have used Java 8 plus.
Okay.
Right.
Okay.
Okay. I will tell you the benefit of it. And when you should say this. This is a very um, ad hoc decision you will have to take. Like let's say you know that the interviewer is if let's say he has introduced himself and said like I'm like 15 plus 20 years of experience, right?
Okay.
In that case, you can certainly say, I know Java. I have started using it 8 plus.
Okay.
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 I am using Java 10 or 11 now. Java
Okay.
10 and 11 is completely different than what the Java I have used or someone who is 14, 15 plus years of experience would have used.
Oh,
So the
okay.
question I will have, I might not come with a good question for you. I can only ask you, okay, tell me the difference between the Java 8 and Java 5 or Java 6.
Okay.
That's the only question I can come up with.
Okay.
Because after Java 6, I have also stopped using Java. I have switched to the Scala or the sometimes Python and etc.
Okay.
So it's well suited that you whenever question comes with do you know Java? Yes, I know Java 8 plus.
Okay.
I have used Java 8 since last 2 years.
Got it.
Okay, few questions. Let's say even if it comes like he asks something, I mean, which will be very rare that you would not know collections and everything. The methods in the collections are all the same.
Yeah.
Uh, if he asks some object oriented questions like encapsulation, inheritance, and etc., those are all again very high level
General
things.
question.
Yeah, those you can answer.
Yeah.
Or even if you can buzz it like uh, I don't know all this. I have not given my time to understand this because these are very much uh, uh, covered in the high level Java. And
Okay.
yeah, I know it's very basic, but you can try. Then you can use the negation that okay,
Yeah.
fine, I don't know this.
Okay.
So particular thing I don't know, but Java is a very broader. Java has a very broader spectrum, so you can't say that I don't know Java, or I have any inconvenience with the Java,
Okay. Got it.
right? Even if you
Yeah.
know Python, Scala, that's very good. People are happy, but they just want to hear that oh you know Java as well.
Okay. Got it.
Okay, so coming to the other questions like how will the Spark manage the concurrency, the failures, and the latency over the distribution? Since Spark has distributed your task across the executors, and the driver is managing it, so the performance of the Spark will be decided by the performance of the driver, right? How well he is managing it.
Yeah.
Let's say I am a scrum master and I have a team, I have a project to do, I have 15 days of time to achieve few tasks. If the team fails, That means the people will ask me, right? I was the scrum master, I was the driver.
Yeah.
So someone will not go to the individual team member and ask, okay, fine, what happened? That's a further analysis.
Yep.
But the first and the foremost thing will happen, like how the driver has performed, and the driver looking at the driver's log, you can identify what has happened. So how driver is written, how a Spark driver is written, is very important, which decides the Spark performance, and that's why the uh, Spark is good, or Spark is competing with the Flink or some other similar framework,
Yeah.
because the Spark driver is able to handle the concurrency in a better way. Spark driver is able to handle the failures in a better way, and the latency in a better way. Like I said, like I said, one use case that, let's say I've submitted a job, it got distributed among 10 executors. 9 executor is working very good. One executor is slow.
Yeah.
So how what the Spark driver will do? Can it, like, if that's taking the time, can it again do the repartition, take that partition from that node and put it into some other partition, calculate it, and give me the result?
Yeah.
Maybe it can do, right? Partitions are not on every executor. It's not like it has driver knows that I have distributed my partitions and I have given 3 partition to this. 2 is replica,
Yeah.
but a replica of what? That also I know
Yeah.
because of the hash. So what I will do, let's say the one executor is running slow, I will just let this, since this executor has finished his task, I will ask him to also calculate the other partition.
Yeah.
That's how it handles the latency.
Okay.
And these are very important because how well you are orchestrating your job decides the Spark performance,
Yeah.
and that is very good.
Yeah.
So that's one of the advantages of Spark.
Yeah.
Then obviously it's immutable. Things are not mutable, like you are not changing the states of the same RDD, because if you change it, it will be very difficult for the driver to understand the state of it.
Yeah.
Right? I have given you a task. Okay.
Yeah.
And then I know that I have given you this task. If you change the scope of that task and then perform it, how would I know that what you have done?
Yeah. That's right.
So, in a layman language, I'm just establishing this concept that why mutability will cause a hell lot of problem in the distributed job.
Yeah.
If some executor decide to mutate the RDD, driver will not know that what he has done, because I have the diagram and I have given you that this task. You just do this task. That's all. Return me the state of that, because when I'm calling the action, I want you to collect the state of the RDD and return it back a new RDD. Don't do anything else, because I
Yeah.
have the diagram. I have the pattern in which this job has to be completed. These stages, these many tasks, these many executors. I have all that mapping in my drivers program.
Yeah.
So immutability is important. Sometimes people ask, like, why not mutability? What will go wrong if I have the immutability in this? So
Yeah.
these are the problems will might happen. That the it's possible to have it, but this overhead has to be managed. So if, let's say, if you want to answer this in very detail, like if the person wants to know, I want to create a Spark with a mutable RDD. Sometimes, like interviews with the Google and etc., Amazon, they might ask all these questions when they try
Okay.
to dig into the data structure. So in that case, you will have to come up with an engine which can handle this overhead of ensuring that mutability. If the data structure has been mutated, what changes have been done, how it can be reverted, and what can be done. But yeah, for now, we have understood what mutability brings the problem and why mutability is very safe. It's a fail-safe situation. Either you have failed or you are safe.
Yeah.
So the uh, fault tolerance, since we are making something fault tolerant, fail safe is very important. Like you have to be like okay, otherwise you just uh, keep running, because you see the executor keeps running. Since it's a fail safe, it doesn't fail fast. So there's all these concepts. Okay, fine. I will not delve into. But fail safe and fail fast, there are two mechanisms. So if let's say the person is asking like mutability can give you the fail fast options and etc. But yeah, that comes with another cost. You'll have to write some engine. You'll have to modify the Spark, and you can come up with your own set of something like Databricks or something. You can create your own engine on top of a Spark.
Okay.
That's something completely different. So immutability, in memory, fault tolerant, lazy. Lazy is because the diagram is created by the driver, how this job will be executed.
Okay.
I have to read two CSV file. I have to join those two CSV file, apply some filters, and then get me the, let's say get me the total sale for this quarter.
Yeah.
Right. I have a simple answer, but I have to join the product and the sales table, join
Yeah.
it, get me the answer. So unless I will ask get me the answer, get me the answer is when the executors will mutate the, will create, not mutate, will create another immutable RDD. Till then,
Yeah.
they have their data set, they have joined. After join, they have created another RDD. On that join, they have created the filter, another RDD. On that, they have applied the aggregation, another RDD, and the final RDD will return. So that's how the execution pattern will work. And the driver will be notified that okay, fine, this stage is done, this task is done, this stage is done, this task is done. So in the execution, I can track through the UI.
Got it.
Understand? I'm tracking you from the UI, right? So you have to notify me when your tasks are getting completed. So you have to be lazy. You don't have to execute. If I submit and you execute it, then how the UI will be updated?
Yeah.
So there are so many things, and since it's a framework, so everything is very important.
Yeah.
And that's why laziness is again important. You have to be lazy. You cannot be eager. If you are eager, then the UI will get UI will not have the updated information.
Okay. Yeah.
So all these things, uh, maybe you it's important because all these things are coming right top from my head. It's not somewhere written or etc. But
Yeah.
keep
From
these
your
points. Even if you mention these words or convert the interview in these ways, it will help.
yeah. Sure.
Yeah, because
Yeah.
that's why, I mean, I'm not saying you that why Spark is lazy. I'm not talking about Spark is lazy. I'm also giving you the points like
Yeah.
why laziness is important for the Spark. It cannot be eager.
Yeah. Yeah.
Yeah. All
Yeah.
right. So then comes the last and final thing, like RDG data frame data sets. We will see in the details in the coming slide. Uh, that's not why Spark is important. That's a different thing. But why Spark is better is like Spark has seen multiple frameworks in the market. When Spark was evolving, Hive was evolving, Impala was evolving, Pig was evolving, Tej, Storm, etc. So many frameworks with massive parallel processing uh, technique were evolving, but still Spark survived. It's important, right?
Yeah.
So uh, Hive, Hive is still is something after Spark, you can say. Impala
Okay.
failed. Impala came up with the Cloudera. Cloudera launched Impala. Hortonworks launched Tej, the map-reduce optimized version of it.
Okay.
Yeah, Hive also, what Hive does, Hive create, automate your map-reduce, right? It creates
Yeah.
mappers. It runs the, it converts your SQL queries into the
Mappers. Yeah.
map-reduce and then runs it. So
Yeah.
you get the map-reduce level of performance.
Yep.
On that, some partitioning and the schema concept came with the Impala. You can invalidate your schema and then you can fire those Impala queries, and Impala queries will is faster than the Hive. Cloudera did some engineering beneath, inspired from the Teradata, and but yes, Cloudera and Hortonworks, both of their engineering has not has finally convoluted into the Spark. They all started suggesting, low, use Spark, leave Impala, leave Tej, leave Storm, leave Mahout. Mahout was like machine learning library, the machine learning version of it. Drop. Storm, the Spark streaming version of Apache. Drop. Giraffe, the graph library of Apache. Very famous. Giraffe is used in Facebook. Hive is used in Facebook. Tej is used in Apple, etc., etc. So things are being used in different places, but still the market dominance is still with the Spark.
Okay.
Yeah. So these three lines, like why Spark is better, is not. I have to. I even if I have my answers, this is something which talks about its significance, that Hive has competed with these many engines and still has the survival instinct.
Yeah.
Still, it's in Databrick uh, is a very sellable item written on top of a Spark.
Okay.
And then support for the various languages. Despite the language has there was a time when the R and Octave and the MATLAB was the only library in which the analysis of the data were happening. Data science libraries,
Okay.
where you are doing the analysis of the data, like weather forecasting or some geology related stuff, all the high profile analysis or health, or the genealogy, like where you study the genes.
Genes. Yeah.
All these studies were being done in the MATLAB or the Octave or the R.
Okay.
But now they have switched because they can decode the uh, decode all the genes. I mean, they can run it in the distributed way. So they have switched to the Spark, or they have switched to the some more sophisticated with Databricks or something. But
Okay.
Spark-driven approach, distributed data parallel-driven approach.
Yeah.
Okay.
Yeah.
So that's why this Spark is important. It's very. It has covered couple of key points, key things behind the Spark. Then what happens when you do a Spark job submit? So this hierarchy is also important to understand, and it's like when you submit a Spark job, you get to your application is created. You have submitted an application, a Spark submit, your jar, your class name, your application is submitted to the Spark cluster. Then that will create some Spark job, which will be further distributed into multiple stages, like the number of joins you are doing, your the filtering you are doing, or the aggregation you are doing. Your stages are created, and then the very basic compute what you are doing, like where name is this. So that task,
Yeah.
very basic task, are like the task, the core level of things which needs your processor attention. So task is something which needs your processor attention. Processor, what it does the compute. So basic compute is a task. Basic compute is like where name is this, where age is this, where event time is this, which gender is male or gender is female, etc. I'm doing some basic compute. Sorting will be done, and I will pick all the males out of it. Some filtering will be done. So there will be basic compute will happen for that filter clause. Those level of details are the basic task. So I can observe my slowness in the task and the stages. These two has to be monitored through the Spark UI. All right, so I will take 5 minutes break.
Yeah, sure.
Yeah, or let's say 10 minutes rather.
Yeah. Yeah, 10 minutes is fine.
And we'll be back. I'll just get some timer.
Cool. I'll see you in 10 minutes.